So, hi, and in this video, I want to discuss how to develop match games in Unity. By Unity, meaning Unity 5. Actually, match games are most commonly called match-free games, which is actually a special case. But I am developing a game and a match game which I can't show you for the moment, but we have here a working sample. Um, Now, by match games are a misleadingly simple genre, but if you'll start developing one or doing a game design of such a game, you will find that there are many decisions to be taken, and actually, the mechanics that apparently look so simple are not so simple actually, and there are so many varieties of match games that one can create. So we'll see all this in Unity, in code, and also in the literature. A note here. I'm using Unity 5, which has actually, by having a good 2D support and even also the UI, and I'll be using also some very good components. So, but Unity 5 has simplified, in my opinion, a lot the creation of this kind of games. Okay. So let's get to code, but we won't start. This is the prototype you're seeing here is for it's a swiping model, so that the full rows can be swiped to form new matches, and you can swipe in all four directions. And if there's no match free done, the swipe rollbacks, and otherwise the matches are made. Now, so this is actually quite more complex than a let's say a standard match free model, and we'll start from that. So here we are. Now, this is a very basic match-free game which is based on clicking. So if I click these three, they match. These two, they match, and these so match, and I can exchange position, or well, in this case there was already a match, but I yeah. No, wrong one. And right one. Okay, so this is all handled by clicking. Now, this is actually a slight evolution of a match-free sample project provided by GameLogic. And so I'll be doing everything I'll be doing here relies on two wonderful plugins. One is GameLogic Grids, and the other one is .Twain. So GameLogic Grids provides most of the functionality needed for starting a match-free development. It provides grids and all the spatial logic and distance and even connection functions for grids. And once you have a grid, you can develop your own notion of cell in the grid. So keeping these two things distinct is very important to develop simply a simple and clear model. Starting from their project, what I added was just the tiles exchanging mechanics and little scoring and things like this. So how is the scene organized? Well, you instantiate either via code or directly in the editor. A grid in my case is 8 times 8, and for each point of the grid I provide a class which is a math cell, a cell class, which defines the sprite and the behavior of the cell. Now, in fact, once you have a grid by the variety of grids and cell notions, you'll be able to model and deal with a large spectrum of games. In fact, if you check out Game Logic's infographic, you will see here how many mechanics and how many kinds of player action and notion of matching, which can be matching by color, by shapes and color, by other features, and which shapes actually are considered a match and which not, and what happens what happens when you need a match has happened. So do you destroy the tiles? Do you make some special effects? Do you feed the tiles, evolve the tiles to something else? And then you also have to consider combos and so on. Okay, but now so once what do you actually need off the grid? First of all, well, you need off the grid, you know which cell is in each point, and you need to know which is the distance, at least for the mechanics that you're defining, between one point and the other one. So like and which features, in this case color, are shared by the neighbors of a point. So you may need to know which points are neighbors. Like in this case, only horizontal and vertical cells, neighbor cells, are considered neighbors, but you could also have a case where you consider also diagonals, for example. So this changes the notion of connected set. Looking at the code, if I open my match cell, okay, what do I have? Well, in this case, I have some very simple behavior. So the cell basically needs to know which color, and so in this case, which sprites it's loading, as the logic is simply based if they have the same color, then it's match free. You may have noticed also that only when you click a match, the match actually happens, which may be something that you may want to change. And if I remember well, I have here several parameters that we can switch off and on to change the behavior of the match game. So let's see which parameters do we have. Well, here I'm matching only if tiles along one axis of the same color, but if I disable this, and let's see, okay, so this whole thing is a match. This again will be a match, and also these three here will be a match. But if I activate this only, so this, well, this will be a match because I have it, but this won't. Okay, but if I turn it off, so that's already a choice you're making. And what's cool, if most match-free games actually do enable auto match. So if there is a match, it will be, which can also lead to a lot of cascades, which is a typical feature of match-free games. Actually, for here I have a combo and so on. Then so cascade also a parameter, and the minimal match size, which here I have 3. Now if I put 2, then I get a lot of matches. Let's see if this stops. Maybe it doesn't. Yes, it did. Okay. So, but just as I switch to, then again I get too many matches. So let's put 4 here. Okay. So this is not yet a match, but that was, and as I have auto matching. So now, so this is really a cool trick. If you set up a grid distance, put the sprites on the elements of the grid, then if you put this is the usual and very useful public variables trick of Unity, so that it allows you at runtime so that to change, and so that you can balance and test the game feel of game in the best way possible. That is by running it and changing things while it's running, which is one of the reasons it makes Unity so practical for prototyping. Okay, so now more in detail. In order to develop the match-free game, you need to support um, at least four kinds of action. First of all, you need to allow the player to move stuff around, like by let's say clicking and doing things like this. Let's enable auto match and like this. Okay. There may be other kinds of action that you want to allow. So that's one thing. So let's check my notes. So of course the second thing is to somehow change the tiles. So destroy the tiles when there's a match, or evolve the tiles when there's a match, or all things like this. Then you need to move stuff around automatically. This is fill up the space that's being created, or enlarge a grid, or things like this. So in order to move stuff around and fill up the grids, you need to generate new tiles. So these four things are the kind of four things you must provide for. And like, for example, and in all four things, there are lots of choices that you can make. Like, for example, here I'm just generating new tiles at random, but you may want to ensure that when you're filling up the gaps, you're not filling them up with tiles of the same color, of other variations, or so not purely random, or maybe some tiles are more precious and you want to make them more rarer, and so on. So I kind of separated this four phases of development in four different methods. Another thing I did, I think it's very useful, and it's fully supported by GameLogic's model, is the fact that each cell somehow takes care of itself. So that like I create a notion of target. Each cell has a target when it has to move, and it somehow knows where to go and when it's done. Okay. So this is the basic simple project, but actually, as in most cases in game design, then when there are references, you want to go beyond that, or do something more interesting. So that's the choice, that the kind of mechanics we are working on is based on swiping. You can swipe cells around. So let's move to another project. So this is another match-free game with a different model, a different a way of doing matching by swiping rows and columns, and which we briefly seen before. Now, if you look while I'm playing, you look here at the scene view, you will notice something. Now, first, let's zoom out a bit. Okay, so this is a trick. Actually, was suggested by my friend and colleague Matteo Bicocchi, so-called pupunzi. Now, if I take off the match cell gizmo, you see here how many cells there are. Actually, there are. The real grid is the side of the visible grid times 3, so that when I'm swiping, and if I zoom out here, you can see it better. While I'm swiping, you get the impression that there are tiles are being created, but I'm just moving one row of the big grid, and also the same here. Now here, I should also turn off the light cell grid, which is something we'll talk soon. So while if you check out here, you see in the scene view there's a hole, and and so yeah, it got refilled when the cells are destroyed in the visible part. So that's a nice trick if you want to have so this kind of grid. Of course, you should keep all these sprites disabled, not as I'm doing this, but I'm doing this just to show you how it works. Then there is other things you have to take care of in the model is the fact that you have moving whole rows and columns. And but there's another point which you don't need in the previous model is the fact that you have to work on a hypothesis, because here when I leave I actually do the matching only if a match is formed. Okay, but if I do a swipe which doesn't lead to a match free, then it's rolled back. But other stuff too also, like you see when I'm leaving the cells dock in place, okay, because of course you can't leave them halfway through. I mean, but the mouse, the user does leave it halfway through, so you have to dock the tiles in place when you're moving. So these are all kinds of refinements that and of course once you have your own idea you will meet, but all these things show you, and also the previous variation that we did show you how non-trivial can be to develop a match-free game, and also how many choices there are actually in terms of mechanics. In order to make this more clear, I want to present you another feature. Notice one thing: when I'm doing matches in the scene, okay, if by swiping I make more than one match, okay, see, all the matches are done, are computed before updating the scene. Now this is one of the possibilities. Actually, it wasn't in my first case. I didn't do it this way. Okay, I just did the match that you did, one match which was the one which was closer to the mouse, which I assume was the one you were most likely looking at making. Then I destroyed that, filled up the scene, and went on. Okay, so once I just want to show you that this is a simple choice that you make once you have a notion of grid and you've made each cell sort of take care of itself. Then modifying this kind of logic, it's very simple. So let's go to the code, and here I have the method I'm currently using is check matches, but I want to use check matches only one version. Okay, so let's see where this is used. So comment this out. Okay, and let's use this other one. Okay, so I'll stop here, restart, and soon it's compiled. Okay, so here I'm doing this match, and that is the only one that is done. If, well, in this case wouldn't make any difference because it wasn't, and there weren't other matches found. Okay, you see it gets filled up before computing the other matches. Okay, filled up other matches, and so on. Okay, now notice how it would be very hard to decide, actually would be impossible I think, to decide whether which of the two approaches you want and which one is better without having a working prototype of the game and testing it out and asking people and trying stuff. So you see that, I mean, the game design choice it's often connected to the actual development of a game. So there can't be a strict boundary between mechanics, game development, and game design. I think this example makes it crystal clear. Okay, another technical point I wanted to make is the fact that, okay, so here I'm running under hypothesis. So it is, if I do a swipe action, then did it determine in this new scenario, like in this case, Okay, notice what's happening in the scene view. So I've altered the grid, moved the tiles, changed the situation. No match was made by my swiping. So when I lift the mouse up or the touch up, touch leave event happens, I have to roll back the situation. So in fact, what you need here is the capacity of computing a scenario. That is, situations where the grid that you're studying is not the actual grid that you're seeing, but is another grid. So what I did, in fact, if you have the notion the notional grid, you just instantiate a new grid, which is times 8 by 8, which is always updated when you swipe, and you compute whether there are matches in this other grid. So if there are matches in this other grid, you actually, when the user leaves, you actually do change the real grid to the swipe action that the user did. So like in this case, what is happening in the second grid, the virtual grid, there is a match. So what I'm doing, okay, so there is a match. So when the user leaves, I actually do transform the real grid to the virtual grid, and I do the matches. So that's another nice trick in order to use the same grid logic to handle possible situations, possible evolutions. So some few final considerations. So you find in the post linked lots of the sample projects, the reference to the grids. The grids actually is a paid component, but there's I think a cheap version for square grids. For handling the smooth movements, I'm using a tweening engine, the wonderful .tween, which has also a free and a pro version. Help the developer get the pro versions. I think it's only $10 or so. And so I think I hope that I've given the gist of the idea of the fact that the complexity of making a match-free game and all the possible interpretations, but also these tools and tricks through which you can actually put together quickly prototype. So if you want to see where all this is leading, if you follow me on Twitter, you will see news about this project, because there are many games where, like in You Must Build a Boat and many others, where actually the match-free mechanics is inserted in a larger narrative, a story, or even a managerial games. So I'll hope to hear you soon. Bye.